Hey guys, just back with another C programming video. This video is on increment and decrement operators in C. So this example is taken from the C programming book by Dennis Ritchie and Brian Kernighan. If you're interested in the whole book, you can check it out. So C provides, I'll just read the code description. It's actually just a little example code. I might have to elaborate because it's only half the code. So for this part, it's just a few examples, like chalkboard stuff. So we're not going to debug these, I'll just kind of explain them. So C provides two unusual operators for incrementing and decrementing variables. The increment operator plus plus adds 1 to its operand, while the decrement operator minus minus subtracts 1. We have frequently used plus plus increment variables, as in if C is equal to new line, or if C is equal to a new line, then plus plus n. We've obviously used them in the tutorials so far, so I'm just going to explain them in depth, because there's a difference between them and it can be tricky. So the usual aspect is that plus plus and minus minus may be used either as prefix operators before the variable, as in plus plus n, or postfix after the variable n plus plus. In both cases, the effect is to increment n. But the expression plus plus n increments n before its value is used, so this part's the key. It's the key part. The most important part is here. So but the expression plus plus n increments n before its value is used. Well, n plus plus, excuse me, so while n plus plus increments n after its value has been used. So that's all you really have to remember, pretty much, every time. There are some tricks here though, so I'll just explain them. This means that in a context where the value is being used, not just the effect, plus plus n and n plus plus are different. So for example, if we just have, so if we have if n is equal to 5, then x, maybe I'll start writing these out. So if we have so include stdio.h, forgot the hashtag, so include stdio.h. So if we have int n points to 5, and we have int x, and we have x points to n plus plus, if n is equal to 5, then this sets x to 5. So here x is equal to 5. Because this is the first time where so it's going to increment it after. So if we have, I believe we have to call it again to get the value. So if we have excuse me, I'm like always yawning in my videos for some reason. So if we have x points to n plus plus, and x is currently 5, then in this case it's going to increment n plus plus later on. So not right now. So right now it's just gonna be x is going to point to 5, then it's going to add 1 after the line executes, pretty much. That's what's going to happen. It's going to say x points to n plus plus, so it's not going to increment till the execution of the line is done. Pretty much that's what's happening. But if we have x points to plus plus n, then it's going to increment before the line executes, before the execution. So it's going to be like x points to plus plus n. If x is 5, then it's going to be equal to 6 in this case. So we can just check that here. So we'll do what it was. Set a breakpoint, save and start debugging it. So if we have if I'm in the debugger now in the console, in the debugger console. So if we have if n points to 5, I'm going to step in or step over. So you can see in the variables it says n points to 5. This is just a garbage value. X is a garbage value. So if we say x points to n plus plus, it's still going to be, n's going to be 6, but x is going to be 5. See? So in this case, until because it's setting, what's happening here is it's setting x to n plus plus, right? So just think about that logically. If it's not going to execute, if it's not going to increment until the line's been executed, until we get to the next line, n's not going to execute, that means x won't get to increment, right? Because, do you get that? Because we're going to be here, and now n's going to execute in the back end with a plus plus. So now n is going to be 6. But x was set before n incremented. Does that make sense to you? Hopefully it does. So one more time, right? We set n to point to 5. So then we have, this is just a declaration of x. Then when we get here to this line, x points to n plus plus. So before we execute this line, let's say we're here, n is pointing to 5. So now we get here, x points to n plus plus. So n was, n's going to say, okay, well I'm going to add 1 to myself after the line executes. So we're still here. We're still executing it. It hasn't been executed. Therefore x is going to point to n plus plus. X is going to point to the current value of n because n won't be able to increment until we get to the next line because it increments after the line's executed, right? So x is just going to stay pointing to 5 because x won't be able to catch its increment unless x was set here again to x points to n plus plus. Then it's going to point to 6, and if we get down here, then n would be 7, and x would be 6 up here. So hopefully that you guys understand that, right? But if we have x points to plus plus n, then x is going to be 6 in this case, because, just save and run that again. Because here, n points to 5, right? Step in. Now x is declared, int x. So we have x pointing to plus plus n. So on a if we have the pre-increment, right? So the last one is post increment, so that means it increments post or after. So post means after, right? So it didn't get incremented till the next line. Now we're at pre-increment, which means it's going to increment before the execution, right? So now we're going to have n currently points to 5. Declare x. So we're saying x points to plus n. So which means n plus or 1 plus n, right? So n is 5. So it's going to say, okay, we'll take 5 and add 1 before the line executes. Therefore, this time x is going to point to 6. See, x is 6 this time. So hopefully you guys understand. It's just a little bit of a concept you have to think about logically, kind of maybe with a trick like that. Like it doesn't execute till the next line, and there it executes before. So in a pre-increment, it executes before the line occurs, and in a post-increment, it increments after the line occurs. So the value that it points to in a point, the value that points to the post-increment, will only get what the value is. It won't be able to get what the value is incremented to. So hopefully you guys understand that. What was that? Okay, never mind. Okay, so that's one of the examples. So just some more on the code description here from the book. So if n is 5, then x points to n plus plus sets x to 5 plus, but x points to plus plus n sets x to 6. So that's what we just did. In both cases, n becomes 6. The increment and decrement operators can only be applied to variables in expression like I plus j in parentheses, and then plus plus is illegal. So maybe I'll just show you guys. So like I plus j, or I plus j plus plus, that's illegal. So that's not an expression in C. So that's going to cause an error. It's going to throw an error or an exception. So in a context where the value is, so in a context where no value is wanted, so when no value is being set to, like for example we have x points to plus plus n. In this case, if we just have plus plus n or n plus plus, then the incrementing effect, prefix and postfix are the same. So how can I explain this one? So if we have, so we just really don't need this, and we don't need the x plus equals to. So I'll just save and run that again. So we have x, so int n points to 5. Right, so now we're saying plus plus n. So n should be 6 this time. So n equals n plus 1. That's what's happening. So now if we change this to n plus plus instead of plus plus n, then it should be 6 as well, because it's gonna change after, but it's gonna be saved to that variable itself, I think. So we'll just double check that. So we have int n equals to 5, or n points to 5, then n plus plus, n points to 6. So there you go, because the reason why that happens and before x didn't, so probably some people are confused about that. I hope not. Hopefully I was able to clear it out, but if you still are confused, what's happening here is that n is gonna keep track of itself in memory, right? So even after the line's executed, the execution here will still be setting, n will still be in memory, so it'll know to to increment itself for a later time. Basically, that's what's happening. So when it increments itself after the line executed, when this line executes, after that line executes and we're on the next line, it's still going to know to increment itself, and it's going to keep track of that in memory, right? But if we have x points to n++, then x won't be executed on the next line as well, because it's only going to execute on the line that it's in, whereas the variable that's incrementing will know to increment itself on the next line. So hopefully that you understand that makes sense, because x is only going to execute here if its x points to n++, then that's only going to increment on this. That's only going to x is only going to point to n++ on this line. It's only going to execute on this line. But if we get to the next line, then x won't be referenced on the next line, because it's only being referenced on this line. Therefore, n knows to increment itself on the next line, because that's what it's setting itself to do. It's saying increment, do a post increment, so increment me on the after this line is executed. So it knows to do that, but x doesn't know to do that. So x is just going to point to what the value is currently. So hopefully that makes sense. So that's the example here. So we have, before we did x points to n++, x points to ++ n, now we just have n++ and ++ n. So you guys understand the difference? I think we've done an example like this before, but it doesn't hurt to just do one more. So we'll have I'll have to elaborate here, because there's only half the code here. There's no main function here, so they just did an example without main. So I'll try to think of something for you guys here. So we have a main defined here. We can use it. We're going to need a prototype later on. So actually probably now. Actually no, we'll do it later on. So we'll have a function here called void squeeze. It takes a char s array. Let's just say str. Actually, we'll just go with the s. So it takes a character s array, and it takes an int variable c. So we have here an int I, comma j. So we're going to declare two variables here, int I and j. So here we'll have a for loop. We'll say for I points to j points to 0. So that's just saying both point to 0 pretty much. S of array index I does not equal null. So there's no like actual null constant or keyword in C, I believe. Is there? There might be. Actually, I think there is. It's capital NULL. But in this case, we want to check if it's in the string itself, at the end of the string. So we want to check if the string is at the end. We're going to check if the string is ending, basically, because a character array is a string, and we want to see if it's there's an imaginary null at the end. So here we're going to have I++, so for I points at, yeah, so we'll just have an I plus plus here. So here we'll have if S of array index I does not equal C, S of J plus plus, S of array index J plus plus points to S of array index I. Then on the last line, finally we'll have S of array index J points to the null symbol. So I think either or will work, but we'll just go with that. Yeah, so there is a null, it's all in capitals, whereas other languages it's just lowercase. So C, I think we're going to need a value for C. And we're going to, I think that's not just any other variable, that's asking for an actual parameter, so I'll create something for that. I think we need one, so we'll have, we're going to have to prototype it now. So we do that by just taking that, copying it, code reuse, and then just putting a semicolon. So that's a prototype. Now we can call it in the main function. So here we'll have, we're going to need a character array, S. So we'll just have a character char array the string literal. Just say it points to cake. And we'll have, because who doesn't like cake, right? So we'll have, I was going to do pie, but I thought I'll just do cake. So here we'll have an int C, so it can just be any variable. Let's just say 12. I think that's going to take symbols from, it's going to reference symbols from the ASCII table, I think. I forgot what this code actually does. Okay, so it's going to take an S. So then we can just call squeeze with S and C, I think. So here we'll say squeeze S comma C. There we go. So hopefully this does something. So we'll have a breakpoint here. Maybe I'll just move that up there so we can see everything. Okay, so we'll just save that and run it. So we have S points to cake, C points to the value 12, so we'll step into squeeze. So for I points to J points to 0, and then S of array index I is 0 does not equal to null I, then I plus plus. So have you noticed that? So here's like where's the increments starting. So if we have Notice how I is equal to 0, right? But we don't increment till the next time we call I. Like when the loop returns, we don't increment till then. So that's one of the way that the increment works. It's just something you have to memorize. It's kind of confusing. Because, actually, perhaps that might be because that's the loop condition. That's just something you have to memorize in this case, like I is going to point to 0, j is going to point to 0 in this case. But it's not going to, I is not going to increment till once we loop around to this line, back to this loop, back up here, back up to the for loop basically, sorry. So from here, if I is equal to 0, we go down. If that's true, we go down. Then we come back up. Then I is not going to increment till we step into the second time. So for the first time it's going to be 0, for the second time it's going to be 1. Anyways, in this case we'll step in. So I is 0 if S of array index S of array index I does not equal to C. Then increment. It doesn't equal 12. I believe it's also double checking if it's equal to the ASCII table character. We'll have to check if it is doing that. So I'm going to pull up that on another device here. So you guys can do that too by just going to asciitable.com. asciitable.com, so that'll give you the ASCII chart for reference. So 12 is the value form feed. So perhaps I should change this to like a C. What letter is that? So C has the value in the DEC, which stands for decimal column. C has the value 99, so if it's checking for that, I'll set C to 99 just to check if it is checking for that. I think if it is, though, it should be using quotes somewhere here, but that's okay. We'll just double check if it is. So squeeze, we got through that. Okay, it is. It is. So what's really happening is character. Okay, so we'll run through that again. Then we'll change it back after. So we enter squeeze. I'll step in. For I points to j points to 0, s of array index I does not equal null, I plus plus, so step in. If s of array index I, so s, array s, right, of array index I, so if s of array index I, so the array s, array index I, which is 0, has a value c, but we want the number, right? Because it has the c value points to a number. If we really want to reference the letter, then you can use a single quote like this. But we're not checking if it equals to C, we're checking if it does not equal to 99 because C points to 99. We could have done that by setting this to a single quote like that, if we were checking for that. But if you don't set that explicitly, it's going to look for a number, so just remember that. I believe. So just remember that. So since s of array index I does equal to 99 because the value C on the ASCII table equals 99, this line is going to be false because it says s of If S of array index I does not equal to C or does not equal to 99, then execute the next line. But it does, so that line's going to get skipped to the for loop. It's going to continue. So in this case, S of array index I does not equal to C, right? Sorry, S of array index I did not equal to I is 1. So it's not showing us the whole thing now. So after C we had A, right? So the 99 does not equal to the A. So therefore it incremented. So in this case we have S of J plus plus. So that means S of, so this is where we're gonna need to know that information that we practiced in the example. So in this case we had J points to 0, right? But if you can remember from before, J is not going to increment until the line has been until the next line. So it's not going to, the increment's not going to execute until the next line because it's a post increment. So it's not going to add 1 till the next line. So right now it's just going to stay the same. So it's just going to be S of array index J plus plus, which is really just going to be J, or which is really just going to be 0. So S of array index J, or 0, points to S of array index I. So it's gonna put S. It's gonna take S to point to A, I believe. See? The C got changed to a A. See what happened there? And then J incremented after. So there we go, J incremented 1. Incremented by 1 at the end of this line. So basically at the end or on the next line. It didn't increment, J did not increment till the line was executed or till the next line. If you guys can understand, but if we had plus plus J, it would have incremented right away. So hopefully you guys get the idea. So for I points to J points to 0, so I is 1 right now, so it should be equal to. So it's going to continue until that string is done or null. So for I points to 0, I points to J points to 0, S of array index I does not equal to null, S of array index I. Okay, here we go, S of array index I. So we have 0, 1, 2, so I is not null because it points to K or some value. K, which is some value on the ASCII table. If S of array index I does not equal to C, it shouldn't. It shouldn't equal to the value 99 at least, because the value K has its own value, which is like 100 and something, I think. Then S of J plus plus points to S of I, array index I. So S of, what's J? J is currently 1. So S of array index 1, basically, because J is not going to increment. It's a post increment, so it's not going to increment till the next line. So J of array index 1 points to, sorry, S of array index 1, so 0, 1. So the second A is going to point to S of array index I. which is 2, 0, 1, 2. So that second A should become a K. That's what's going to happen there. So there you go, A, K, K, E. So if we have the next line for I points to J points to 0, then S of array index I does not equal null. Well, S in this case, I is going to increment. Oh, actually, yeah, so I currently is 2, so S of array index I, well, we increment it actually. It's going to be 0, 1, 2, 3, so it's going to equal E, so it's not going to be null yet. So it should be true of I++. So then we're going to have S of array index I does not equal to C. That's true because E does not point to the value 99 on the ASCII table. It should have a value of like 101 or something. DE, something like that. So then we'll have S of array index J++. So J++ is going to be just J because it's going to be 2. Then that J is going to increment on the next line because it's a post decrement. So S of array index 2, 0, 1, 2 is going to point to S of array index I, 0, 1, 2, 3. So that K, the last K is going to become an E. We have A, K, E, E. So now I is going to increment 0, 1, 2, 3, 4. So in the last case there was a null at the end, an imaginary null. So after A, K, E, E, there was an imaginary null at the end of the string. Therefore this line was false, and it skipped this one, which this one was only true if this one was true, so then it skipped down here. So S of array index J, which is 3, points to null, so 0, 1, 2, 3, so that last K is going to point to null, and it's going to take that E out, and it's going to squeeze them together. Basically, it's squeezing the string together. That's the point. So there you go, we got A, K, E, and an imaginary null at the end, which you can't see. So that's the code example. Hopefully you guys understand. If you guys want to practice, you guys can change this to ++j, which is just going to increment it right away. We kind of already explained that, so hopefully you guys understand. It's enough information to understand. To run through this code again, obviously it's going to take a while, so if you guys really want to, just change this J++ to ++j and just practice it in the debugger the same way, if you guys still aren't understanding completely. And I hope you guys enjoyed the video. If you guys like the channel and the video, you can like and subscribe to the channel for more coding videos. And if you guys like investing or trading, I do that stuff on this channel as well, including coding, trading stuff, like bots, trading bots and stuff. So yeah, thanks for watching, and I'll see you guys next time. Take care.